the length of a piece of string might be 3 centimeters. And if it's going to the left, you might say, well, it's at -3, but its length is 3. And so the modulus of 5 is 5, and the modulus of -5 is 5. So it only really affects the negative one. The positive is the same. So a speed of a car is 30 miles per hour. If it's going to the left, you might say its velocity is -30, but its speed is just 30. And so it just affects the negative. And you can do these. Do you have, what calculator do you use? Graphical, normal?
Yeah, graphical.
Okay, graphical. Menu, run matrix is 1. And you can do, math is F4. Press right. No. Oh, yes, F3, absolute. And then you can put in whatever number. I'm going to put in the 2 fractions, the part C one. One, 3. And do you have did you find it?
Yeah, I got it.
Okay. And so what did you get for -2?
2.
Yep. And so that's all there is to that. There we go. -2 becomes 2. That one becomes, yep. Oh, hang on. What is the modulus of 6.5?
6.5.
Yep. Okay, how do you do this?
You substitute whatever like the number is. So like the first one is just 8.
Let's see. Yep. How about B?
So if you put -2 into 2x minus 3, you get -7, but because the modulus is just 7, so it's 8, the
So
answer.
that's going to be 8 as well. Modulus of -7. Oops. And let's see. That is 7 plus 1, that is 8. So they're both 8. 8, 8. Yes. And you can always just use it put the whole thing in your calculator. Sketch the graph of modulus 3x minus 2. So basically the positive y coordinates are fine. It only affects the negative y coordinates. They become positive. And so instead of it being, let's say, -3 minus 3, it becomes -3 plus 3. A few different ways to do it. Let's graph it. Menu 5, graph. This time you have to press Option first to find the numeric stuff. Let me delete this. And so it is press Option and then numeric F5 and then absolute. 3x minus 2. And draw that. And that's what it looks like. And there are certain things you can do. How could you find the y-intercept?
You just press G solve and then y-intercept.
Yeah, shift graphical solve y-intercept, and it is 2. Try finding the minimum. What does it say for that?
2/3 and 1.44 times 10 to the -11.
So what it's struggling with there, so it's basically 2/3. And for whatever reason it doesn't say 0. It should say 0, but for whatever reason it struggles with it. For, just like normal, to find the y-intercept, you let x be 0, and then to find the root, you let y be 0. And so it just struggles to deal with that. And there we go. So the y-intercept is 2, and the x is 2/3. You can always just draw the normal line, and then it's like it bounces off the x axis. Any y coordinates that were negative now just become positive. Any questions there?
No.
And I should mention menu. How do you do table? Table of values with this thing. I know how to do it in the simple one. I'll just do a simple calculator. Menu table is 9, is it? You can always just do shift left bracket for absolute. 3x minus 2. G of x is blank, and let's say we go from -5 to +5 in steps of 1, and then you have a bunch of coordinates, and that might help. Okay, that's good. Oops. Okay, how do we solve this?
So I think one way is you just do like 2x minus 1 equals 5. Like you kind of just ignore the modulus.
Yep.
So then you get 2x is 6 and x is 3. And then the other way is you times by minus 1.
Yeah, so what would that one be?
So it'd be like minus 2x plus 1 equals... Would it be equal to -5 or 5?
Only one side is the negative.
Okay. So it's just be 1 minus 2x is equal to 5.
Yes. Or you could do it this way, because there's only one thing on the right side. Both ways get you the same answer. So this one is x equals 3. And how about this one?
X equals minus 2.
Minus 2. I should just as well... Nah, oh bother. I put it in my calculator. No, I didn't. I left something out. They did it graphically. Nah, let's just keep it simple. Okay, how do we do this one?
Isn't there a method where you should like square both sides, but you're not meant to do that one?
You are meant to do it. Let's do it. Let's square both sides. See what happens.
4x squared minus 1 is equal to 25.
So that's 2x minus 1 squared equals 5 squared.
Minus 1. Never mind.
4.
X squared minus 4x plus 1 is equal to 25. So 4x squared minus 4x minus 24 is equal to 0.
Yep. Equation. Polynomial 2.
X is 3 and x equals minus 2. But I swear it doesn't always give you the right answer.
Why doesn't it always give you the right answer?
I don't know. I just, like, in school they told us, like, you should be careful when you use it. Both sides. Because sometimes it can give you an answer that isn't there or something.
Nope. It'll always work. I think I know what your teacher's on about. And I'll show you. They're talking about inequalities. But they're wrong. Or maybe they're right and I'm wrong. Who knows? Okay. This one.
3x minus 5. So first you just like solve it like normal. So x equals 2. I got x equals 2 when you just solve it as normal.
Okay.
And then when you times by like minus 1, I got x is equal to 1.2.
X is equal to 1.2. I think I know what they're talking about. But let me just be silly. So 1 was 3x modulus 3x minus 5. 1 was 2 minus a half x. This is what they look like. Make it look a bit better. View window, is that the standard one? There we go. That looks a bit better. Shift, graphical solve, intersection. One is 1.2. Press right. The other is 2. Yeah, I like that. And I cheated with this calculator. 1.2 and 2. Okay. Grand. Here we go. How do we do this
one? So first you just solve it like normal. X is greater than a half. And then do it the other way. And X is less than 1/8.
X is greater than a half. X is less than an eighth. You seem confident.
I don't know if it's right though.
How would I do this one? I would square both sides. 5x minus 1 squared is greater than 3x squared. 25x squared minus 10x plus 1 is greater than 9x squared. Is that 16? 16x squared minus 10x plus 1 is greater than 0. I would then do simple calculator. Menu B for inequality. Degree 2. Greater than 0 is option 1.
Half and 8.
And was the thing going the same way?
Oh, I didn't do it in inequalities because I don't know how to do inequalities on this.
So you decided to think instead of not think. That's the difference between you and me. But you got it right. I'm happy. Any questions there?
No, so you can use like any method. It doesn't matter. You'll still get the same answer.
Yep, many different methods. So okay. I just did menu B for inequality, and it just makes sure that you get it the right way around. They did a graphical method, and they said, when is this graph greater than this graph? It's greater than it to the right of a half and to the left of an eighth. Great. Okay, exam question. Ba-ba-da-boo. How do we do this?
To sketch it, you just find the y, not the y-intercept, the x-intercept.
Root.
And y-intercept, actually.
Yep.
And just draw it. So
using graphical calculator, is it?
Yeah, I would use a calculator.
Go on, calculate it. We'll do one exam question.
The y-intercept is 3.
Right.
And I'm not sure what the x-intercept is.
So yeah, it doesn't like that for some reason. You might just have to make y equal to 0 and solve it manually.
You think it would give you -3/4?
Yep, I think it is. So I think it looks something like that.
Why does it not like the x?
I think it is the method that it uses.
Because it said sound when I tried it on my calculator.
So you'll get something similar. So I use my simple calculator to cheat, and I do shift left bracket for absolute 4x plus 3, and I want to solve that. Shift solve. Let's go with lucky 7. There you go. It did work. Sometimes it works, sometimes it doesn't. Now on graphical solve uses, let me lucky 7 was too lucky, I think. Let me try something less lucky. Shift solve -9. No, who knows? Sometimes it works, sometimes it doesn't. Any questions there?
No.
Okay. And solving this equation, it's you're good. This stuff, find the value of x for that. That's okay. We're good for these.
Try f of x equals x.
Oh, that's too easy. Okay.
Oh, is it just like 5 minus modulus 5 minus 3x is equal to x?
Yep.
Okay.
This one on the right, you did one that's similar to that, so you're gonna be fine. You got a first shot. Let's see. You can do inequalities on the graphical calculator as well, so you can make it actually doing inequalities. But anyway, sketch the graph of that. That's fine, and then find the values of x. I think that's also fine. It's just lots of calculator stuff.
Yeah.
That's the same. This is worth doing. Let's try 13a.
I mean, it says the solution is at the vertex of the graph, so it's like the minimum of the graph, basically, I think.
You cheek this man in the face every day. There. Has exactly one solution. How do you do
that? Wouldn't it just be 6?
I don't know. How do you get 6?
No, that's just where the minimum point of the modulus is, but I don't know how to do it.
Let's see. So at the minimum, that's...
Oh, you could do that thing that we did that thing called like the discriminant.
Discriminant. Yeah, that's another way to do it. I'm just thinking, since it's a 2 marker, if there's only one solution, 6 minus x is equal to a half x plus k. What would this look like if you were to graph it? 6 minus x. Modulus 6 minus x.
Yeah, it's a modulus function with at like 6, 0 with the like corner bit, and the y-intercept is also 6.
So that's going to have a y-intercept of 6, and then x root of 6. So that's 6. That's 6. A half x plus k is going to look something like that.
Yeah.
And if they have only one root, then it has to go through that point.
Yeah.
So how can you use that?
So it goes through 6, 0. So that's when x is equal to 6.
Yeah.
So you can just substitute x is equal to 6. And then k is equal to -3.
So k equals -3. State the solution to the equation.
X is 6.
6, 0 or something like that. So k is -3. And then
Yeah.
x is 6. Yep. Any questions about
Not really.
that? So modulus
Oh,
function.
I don't know why I found it so confusing, like when we did at school.
They get more confusing. Don't you worry.
Uh,
Functions and mappings.
I know this, but I don't.
Hang on. If you know it, you know it. I just want to see. There's some modulus stuff that they throw in here, I believe. Do you know how to do this in your calculator? In your graphical calculator?
No.
I will show you some magic. Next page. See how I did these square brackets after it?
Yeah.
So you do comma and then square brackets by shift plus and shift minus. And that does it for those things. You leave it blank for infinity or negative infinity. So 5 minus 2.
1. Like, what do you put in the square brackets?
So square bracket, if it's going to negative infinity, just leave it blank.
Mm-hmm.
And then comma 1. So it's just like blank, comma 1, close square bracket.
Then x squared.
And so one of them you just get like part of the graph.
Yeah.
And then the other one, x squared plus 3, comma. There's a comma. There we go. Shift plus 4, open square brackets. This time it's starting at 1, comma, leave blank for positive infinity. That'll just keep going. Shift minus 4, close bracket. Draw. And there you go.
It's like a weird, yeah.
And, well, they told you to sketch it. There you go. There's your sketch.
Is that, that's what it looks like?
Why,
Wouldn't they be like connected? Like
nope.
joined?
Nope.
No?
They are not connected. And in fact,
Oh, one is less than and one is greater than equal to. Yeah, makes sense. The range, my favorite thing.
Huh?
I don't get range. Range
Range
is the Y one, right? Isn't it just infinity? There's like a point where it starts at, but I don't know.
Lucky Lou. Can I get it to go down that far? So it's down, the x is 1.
Y is greater than or equal to 3.
For the first one, it says x is less than 1.
Yeah.
And so it would be y is greater than 3, not greater than or equal to.
Okay. Okay, because you have to, yeah. And then would the second one be y is greater than or equal to 4?
Yep. Okay. And
my graph doesn't show, my calculator doesn't show like those squares. I know how to do that.
I just did shift zoom in. So what helps is like shift view window, and you can choose something like standard. And that kind of makes it a bit more manageable. And then from there, you can do shift zoom in.
Oh yeah, I can see, but it doesn't give me squares and numbers, but I can guess.
Did you do shift view?
Yeah, I did.
Then shift zoom.
Like I can see it's at 3 and 4. There's like little lines, but there aren't like numbers.
Okay. Well, you can always, don't forget, shift graphical solve, let's say minimum for the first one. Ooh, that didn't work. Okay, hang on, there's another way to do it. Shift graphical solve, press right, and you can do y calculation.
Oh yeah.
So when let's say for the first one, when x is 1 equals y is 3, and we know x is less than 1, you know, so
okay.
yeah. You're not finished just yet. GCSE
solve equals 19.
Hold on, slow down. GCSE, that's 0, That's 3. They've got some inequality. What inequality is that?
X is less than 3.
What does x is less than or equal to 3 look like?
Oh, the circle has to be filled in.
Yep. And so this graph here looks like that. The other one looks something like that. They have circles at the end of them. What type of circles do they have?
Oh, the bottom one has a not filled in one.
Yep.
And the one has a filled in.
Well done. That's how it works.
Do you have to draw them like that?
Sure do.
Okay.
What else was I going to say? Yeah, B. How do we solve this?
Well, I'm not sure if you have to solve it for both of them or just one. Wouldn't you just do 5 minus 2x is equal to 19 and then solve?
Yep. What would you get?
And then you do the same thing for x squared plus 3.
Yes, well done. And you know me, I'm going to cheat.
X is equal to minus 7. And then x is equal to plus minus 4.
That's probably right. Let's see. I'm going to say you're half wrong. You're 2/3 right. I'm going to go to this one. Shift graphical solve. It's an x calculation. So for the second one, the x squared plus 3, this is when y is 19.
Oh, you can't have minus 4, so it has to be plus 4.
Yes, it's only half of the graph, or it's only part of the graph, and so you cut out that one. And so x equals
7 or x equals 4.
7 or x equals 4. Yep.
Mm-hmm.
And now you're 2 halves right, meaning all right. Sure. I saw lots of stuff, but I didn't see the answer. Yeah, x equals plus or minus 4, but then just 4. And then x equals minus 7, was it?
Yeah, that's what I got.
Okay. Any questions about any of that?
No.
Okay, what a time to be alive. Graphical calculators. Okay, your favorite.
Range. Calculator. Y is greater than or equal to 1.75.
Is it?
Yeah.
Okay. B.
The minimum point is at 1.75. So
B.
It's 1-to-1 because otherwise it wouldn't be a function. I think it's 1-to-1 because it doesn't go beyond 0, so that can be 1-to-1.
I think one to many is a different type of function, but not many to one. Something like that, or not many to many.
Yeah, okay. But I think this one is 1-to-1.
Maybe. Let's see. I'm not even thinking. My thinking days are over. X squared minus 3x plus 4. And then the important bit, comma. Shift plus. It says x is between 0 and 4.
Yeah, I did that.
Oh, great. Shift minus draw. Okay. See at the 4, we need a, at the 0, the y-intercept is 4. Okay, we need a dot. What's the dot?
Filled in.
What about at the other end?
Not filled in.
Yep. And so y is greater than or equal to 1.75. And then we have that thing. That's at 4. This one is filled in. This one is not filled in. And what's the x coordinate on the other one? Oh, sorry, the x is 4. What's the y?
8.
Trust you. Oops. Hang on. Because there's a stop point, isn't there?
Oh, okay. So you have to include that in the.
Aha. So the y isn't just greater than 1.75. It's also less than 8. So it's in between those two. Yeah, there you go.
Many to 1 for some reason.
And it is many to 1.
I don't know.
Because let's say when y is 3. Shift graphical solve. X calculation when y is 3. How many solutions are that?
Oh, there's 2. Okay, yeah, then it's meant to 1.
Yeah, and so 2 different x's give you the same y, and so many to 1.
Yeah, that's meant to 1.
Any questions about that?
How do you figure out whether it's 1 to 1 or many to 1?
This is how.
Okay.
Many.
You just pick a point and then check.
Yeah. So I mean, I kind of know from experience that quadratics tend to be many to 1.
Okay.
Because they've got that shape, and so you've got to, you know, that would work. But it would work for anything, for a cubic or something. Straight line is going to be 1 to 1. You made me skip it. I would have gone over it here. 1 to 1 or many to 1 for each of these?
Oh, 1 to many. The first one is 1 to many.
Okay.
So it's not a function.
Yeah, so it's not a function.
The second one is 1 to 1. It is a function.
So that's 1 to 1. That's a function.
The third one. I think it's 1 to 1, but I'm not sure.
It is 1 to 1. It's a very strange one.
It's a function.
It is a special type. It is not a function because
It's not continuous.
Because it's not continuous. Yep.
Okay. And then the second one, the last one is many to 1, and it is a function.
Many to 1, and it is a function. Maybe I'm totally wrong about this. Let's see. So the first one is 1 to many, not a function. Hang on. So that's 1 to many, not a function.
It's never a function.
1 to 1 function. This is 1 to 1, not a function because it doesn't get mapped, so not a function. Many to 1, and it is a function. Great. Any questions about that?
No.
You're good. You're good. We did so much stuff there. Sketch this graph. Is this worth doing?
Calculator.
Yeah, just calculator. And state the range of the f of x. Do I have a graph? I do. What? Honestly, this is my graph. What is the range?
It's greater than or equal to minus 10.
Yep. Greater than or equal to minus 10. Grand. This is worth doing, I believe.
Okay, I'm just going to graph it first.
Great answer. Sorry, I need to move that. There we go.
Well, if it's 1 to 1, then it has to be at the minimum point, I think. If you want it to be. A would be greater than x is greater than 2.5, right? Or
Greater than or equal to 2.5?
yeah.
Let's see. And so I think A would be 2.5.
Yeah.
Shift, capture that. And let us take a look. X is greater than, 2.5. 2.5. 2.5. Yep. This looks very similar. Sketch this and then find the values of A to suppose the P of A is equal to 50. How would you do them? I think you're going to be fine for that.
Yeah. You just do solve each one and then check it's within the range of solution.
50, 50, 50. Yep, that's fine. And then this one, h of 4, state the range of that one. The exact values of x for which the h of x is equal to 5. So how would you do D for this one?
So you do 2 plus x is equal to 5, and then you solve. So x is equal to 3.
And for the
And you
second
do it in the other one as well.
one?
10x minus x squared minus 17 is equal to 5. Yeah. Calculator.
So I get 5 plus or minus root 3.
Yeah, that's what I'm getting.
And so
but only one of them is in the range.
which one?
5 plus root 3.
Well done. And so x equals 5 plus root 3. And then the other one was
3. X equals 3.
X equals 3. Great. I was just checking that you would remove the negative one. The solutions, and they just wrote.
But it's just out of range. But yeah, I see what you mean.
Okay, let's see this one. The function is linear. It's a bit different. The function is linear. Okay.
So you just draw a line, connecting those 2 points.
Yeah.
Yeah, those 3 points, sorry, because it's basically the same.
And I'll test you. So from minus 10 to 6. So minus 10, 14. Do I have
Yeah.
this? Okay. What is the range?
It's greater than or equal to minus 4, and then it's less than 27, less than or equal to.
You are half right. Minus 4 is in x coordinate.
Oh, I meant 2.
Yes. And so, yeah, y is between 2 and 27, and both included. Great. Any questions there?
No.
Okay, and you could also just graph y equals 12 and just say where do they intersect.
Yeah.
Lots of ways you can do the second one. We did one like that. That's good.
Yeah.
Okay, functions and mapping.
I understand it. Yeah, but hard.
Composite functions may not involve modulus. It might though. Let's just go for modulus. What does this mean? F squared x.
It's like 2 f's, as in you have to apply f twice.
Yeah, f of x. Okay, this has some modulus stuff.
Yes. FG3. That would just be 2. So I don't know if you're meant to get 2 answers, but I got 2.
For which question?
For the first one. A.
How'd you get two answers?
Because when you do g of 3, you get 2.
Right.
Oh, wait, it's not solving the modulus. Never mind. It's just one answer.
Mm-hmm.
And it's 4, because it gives you -4, and then there's modulus, so.
So that is 4.
That's it.
That's the g of 3. We want f of g of 3.
No, that is the f of g of 3. Because when
sorry, 3, 4, you put 2 in. Yep.
Yeah.
4. B.
X is equal to x. So you do modulus 2 in brackets x plus 1 over 2. Wait, no, that's wrong. Never mind.
What's wrong about it?
Oh, no, it's not wrong. I just confused myself. -8 is equal to x.
Don't forget to close your modulus.
Yeah, I wrote it. Okay. So then you just get x plus 1 minus 8 is equal to x. So x minus 7. And then you just solve it like you would any modulus.
Mm-hmm.
So x minus 7 is equal to x. Oh, wait. X is equal to -7 over 2, or x is equal to 7 over 2.
What is x minus x?
Why would you have... Oh, that one's x minus x. That would just give you 0.
No solutions.
Okay, never mind.
Or x equals 7 over 2. Okay, so just watch out for that. No solutions.
Yeah, I
Business. Yeah. 7 over 2 is the same as 3.5.
Oh, this is like when you can't do the squaring, because if you squared it, you'd get an answer for that, I think.
Maybe. Okay, let's try it. So,
I don't know. They just told us not to do the squaring one. I'm not sure why.
Maybe they're right. Let's see. So, they're totally wrong. Oh, maybe they're right. Let's see. X minus 7 equals x.
But you still have x squared on both sides, so.
Equals x. So, x minus 7 squared equals x squared. X squared.
Minus 14x plus 49.
You would get an extra answer there. So 14x 49. X equals 7 over 2, but you get plus or minus. No, you don't. You get 7 over 2.
So 7 over 2. Okay. Then the squaring method works as well.
Worked again. Another victory for the squaring method. Let's see.
Okay.
How would you do? How would you do?
But it's not confusing.
How would you do? No. I think you're okay for this one, right?
Yeah.
You're fine. There's no modulus there. That's off.
Modulus either.
There's a bit of a modulus in 5, but we just did one and you did fine.
Oh yeah, that doesn't have modulus. But
No modulus. Yeah, you can see there. State the range. I just graph it. I was like, here's the range.
Yeah. I don't know how you would do it if you didn't graph it. So, is there like a way of like figuring out the range without graphing it?
Yep. This one. Another.
Just find the minimum because.
Yeah, find the minimum or the maximum.
Maximum, yeah.
And
the graph is easier. That's too much effort for one.
You could do f dash of x. And
isn't that just differentiate?
Yeah, so you just differentiate it Make that
I get so confused between f dash and like f minus 1.
inverse.
Yeah, I just get confused.
Let's see this one. That's okay. Find the expression. This is alright. It's alright. So they're just using e and ln. Solve this equation. That's just into itself. What's the range for this one?
X is less than 12 and greater than minus 8.
Do you mean y?
Sorry, yeah, y.
12 minus 8. What is the domain?
Minus 5 to 14.
There we go. 14. And I'm saying y, but they often say f of x because you might have like 3 different equations: f of x, g of x, h of x, and they all have y.
But
yeah, that is the range. And the range was minus 8. Hold on, why are they saying x? That's wrong.
Yeah, it should be y.
It should be y or g of x. Oh, hang on. G of x? Did they call this g of x?
Yeah, it says the function g.
That's should be g of x. Yep.
But x is wrong.
Yeah, clearly that's the y-axis. Yeah, that should be y. X in misprint. Composite functions.
Yeah, I'm fine with it.
And inverse functions. Sorry?
I know how to do inverse.
I want to see if there's a modulus in here.
Oh, I might not know how to do that.
Doesn't look like there is. Probably because they're not functions unless you limit their domain.
Yeah, that's true.
Maybe they are. Maybe they're many to one or something. I'm not seeing that. Aha! This one. How do we do this?
Yes. So the first one is just a quadratic, x squared minus 3x minus 10. Because it's just normal y equals f of x. So x. And then the second one is like the whole thing is the modulus. So it would just be it's like a weird
did you just do the modulus of everything?
Yeah.
I'm happy with it. And how would you do C?
Not sure.
Whenever
there's an x, you have to put like a mod around it.
Yeah.
But the 10 is not in the mod, so you just have mod x squared minus mod 3x minus 10. I think.
Very close. It is mod x squared minus 3. So the minus 3 is outside the mod.
So you just put all the x's in a mod.
Correct.
Okay.
Go on, sketch it.
I'm trying.
How do you do absolute again? Option numeric. That's
Option
it.
number. Numeric. Whatever.
X squared.
I think it's negative. Like it starts off below the x-axis and then sort of goes up. It's kind of like a quadratic though. Half quadratic.
Yeah.
Ish.
Let's look.
Explain it.
Shift. Zoom. Let's try auto.
Oh, it's not half a quadratic. There is. I don't know. It has a weird shape like this.
Shift view window standard. Yep, that's it. And
I describe the shape.
so the first one, B
Yeah,
is
that's something like that.
and the second one looks like that.
Hmm.
Yep, that's good. There they are. Let's see. How would you do this?
So the first one is just a normal sine graph.
Yep.
Then the second one is the whole thing in mod.
Yep.
So it's just sine x in modulus, which I can't see for some reason.
This one,
Oh,
you
it
would
looks like a line.
change your view window to trig.
Oh, yeah, I did that. Okay. Yeah. And then the second one would just be sine, and then only the x is in modulus.
Yes. Hold on. So, question C, sine.
Yeah, it's like an upside down sign.
Yep. X
Sort of.
and shift view window trig. There we go. Woo! So look like that.
Yeah.
Okay. And there's a reason for that. So that's those. Oh yes, and this one said from minus 360 to plus 360, and
Yeah.
so I just did comma minus 360 comma
Okay.
plus 360. Okay, this time no calculator will help you because they did not give you the h of x.
Catch each labeling and inputs.
So any idea how this works?
I think the first one, since y is equal, if you have like a negative x coordinate, you just like change it to the positive one.
That is the second one, not the first one.
Oh, this is when anything below the x-axis gets like reflected.
Yes. So let's say the 0.6 minus 5. What does that become?
6, 5.
Yes, that becomes 6, 5. And so
The shape becomes the same, but just on top of the y.
So anything negative becomes positive. Anything positive stays positive.
Mm-hmm.
So that's going to be like something like that. And
Yeah.
that is 6, 5. How about B?
The one that's like minus 2.5, I think that would become 2.5, 15, but I'm not sure how.
Wrong.
Okay.
Totally wrong. I shall tell you why. It's an easy mistake to make. Y equals x cubed. When x is 2, what is y?
8.
When x is minus 2, what is y?
Minus 8.
When x is modulus minus 2, what is y?
8.
Yes. And so the modulus of a negative is the same as a positive. And so the negative...
Same.
Sorry?
So it's just the same graph.
It is like a repeat of the positive side in the negative side.
Oh, okay.
So let's say 6 minus 5. What would that become?
That would be minus 6 minus 5.
Well done. Minus 6 minus 5. And so it's like a reflection of the positive side in the...
that makes sense.
Oops, I shouldn't have another root. Something like that. And yeah, and so it looks like that. So when you sub in 6, the y is minus 5. When you sub in minus 6, the modulus of minus 6 is positive 6, and so you'll get minus 5 again. Great. Any questions there?
Nope.
So there's a million exam questions that are similar to that. Okay, let's do what's part A?
So P would be... 3, 5.
3, 5, and
For that though, would it be? I'm confused as to how that would look.
positive part stays the same.
Yeah.
Bounces.
Okay. That's what I thought, but then I was like, ugh,
Positive part stays the same. And so that is going to be
I don't like it.
something like that. Part B.
So you just do like a reflection basically of the graph. So at the y-intercept, which is 4, you start going down again,
Yeah,
down to -3, -5.
that's it. And so 3 minus 5, I suppose repeats to be -3, -5. It doesn't change as such. It's just a repeat of it. And so it's going to look like that. Yep. There she is. Great. Any questions there?
No.
Okay. And so they're all going to be the same thing. For the Y one, it's going to be like that. And for the X one, the left side is totally obliterated and it just becomes a repeat of the right. And there they go. And there's nothing more to that. If they give you the equation of the graph, you can just put the whole thing in a modulus.
Yeah.
Or just the x in the modulus if they give you the equation. If they don't, you can just do it the way we did. And so those x1/2 or tick.
Tick.
So that's all of modulus, I believe. Other than that, there's only transformations, but they don't involve modulus.
That's fine.
How was that for you, Amogha?
Pretty good. I understand it now.
Any topic in particular you want to do next time?
I saw this question in a past paper. I'm not sure what topic it is, but it's like find the volume of the revolution by integration. I have no idea what it was.
What's his name?
I think it's further maths, so but
Gregoire wanted to do that as well. I'm doing further maths with Gregoire as well. If you want to do further maths, if you just tell me beforehand, I can prepare. Because like A level, I have most of them prepared. For the maths, I don't. Volume of solid of revolution. Yep. Any other questions in general?
no.
All right. Well done, Amogha. You did great. And I'll phone at 5 next time.
Thank you.
All right. Have a good week. Goodbye.
Bye.